Hi, Miss.
Hello, how are you? Can you hear me?
Yeah, Miss, I can now.
Okay. Okay, so we're going to start with periodic table today, and hopefully we're going to end it as well because it's not that long. And I was thinking we complete principles of chemistry as the first topic, and then we go on to the last topic, and that is electrolysis, right? So
Yeah,
what you were the one who I gave a trial class in electrolysis, right? If I'm not wrong.
yep, yeah.
Yeah. So like we've already had a class, but obviously we're going to have another one just to cover up the concepts and everything. And once we're done with the whole principles of chemistry section, we'll start with past papers for every topic. Okay?
Okay. Miss, also in school we started organic chemistry. So
Right.
after we do the past papers, can we just start with that?
Yeah, sure. You can do that. Okay, so let's start. So this basically has a lot of notes. So make sure to copy that. Also, if you have access to all of the notes and the recordings, right? They're working for you. Did you try playing one of the recordings?
Yes.
Okay, great. So let's start the arrangement of elements according to an increasing proton number is called a periodic table. Basically, your periodic table is divided into two parts, where one goes from left to right and the other one goes from top to bottom. So the one that goes from left to right, this is called a period, and top to bottom is called a group, right? So you in total have 7 periods in your periodic table and 8 groups in your periodic table. So what the period number tells you is the number of shells, while what the group number tells you is the number of electrons in the outermost shell,
Yeah.
right? Outermost shell can also be called the valence shell. However, we do have some exceptions here. I'll write them here. इसमें there is hydrogen, which is not in any group. And then there's helium, which is in group 8. Okay. So if I have this element X that has a proton number of 7, what is the electronic configuration going to be for this?
Uh, the proton number is 17. Okay. So it's gonna be 2, 8, and 7.
Great, good. Going to be 2, 8, and 7. That means that the period number is going to be, what does the period number tell you? Number of shells, right?
Yeah.
So how many shells do you have?
Uh, one. Um,
Okay, if I
wait,
draw
what?
this
11?
element, if I draw this
Yeah.
element, we have 2 electrons in the first shell we have 8 electrons in the second shell. And then we have how many electrons in the third one?
Uh, 7.
Right. So how many shells do we have?
3.
3, right? 1,
Yeah.
2, and 3. 1,
Yeah.
2, and 3, right? So your period number is going to be
3.
3, right? And what's your group number going to be?
Group number is gonna 7.
Right. Another example, if this is my element, my electronic configuration is going to be 2, 8, 8, 2, right? This makes 10, 2 plus 8, 10, 18, and then 20, right?
Yeah.
So what's the period number going to be and what's the group number going to be?
The period number is gonna be 4. The group is gonna be 2.
Right. So now that we're done with the introduction, we move on to specific groups. We're going to talk about group number 1 first. This group is called alkali metals. And we're also going to write notes side by side.
Okay.
This is group 1 called alkali metals. So I'll write the properties first. So these metals are soft metals. You need to learn all of these properties, okay?
Yeah.
Number 2 is these metals have low melting points. Less than 100 degrees Celsius. Okay. An example for this would be sodium that has a melting point of minus 800 degrees Celsius. Point number 3 is these metals are highly reactive. Now, these metals are so reactive that you cannot keep them in open air. Okay, they're probably going to react with air as well. So what we do with group 1 metals is we store them in oil. Okay,
Yeah.
oil stops them from reacting with the air.
Okay.
These metals also, like since they react very much readily with the air, they also react very readily with cold water. Point number 4 is the reactivity of these metals. So when we talk about reactivity, we also talk about the concept of electropositivity and electronegativity. So reactivity itself is the ability to gain or lose electrons. To gain or lose electrons. So gaining electrons is what's done by metals, is what's done by non-metals. And losing electrons is done by metals. Why do you think metals are more likely to lose electrons? Can you hear me?
Yeah.
Okay. Why do you think metals are more likely to lose electrons?
Um, because of the reactivity, they're more reactive.
Yeah, that is true. But if you see, metals usually have an oxidation state of
One.
they have a positive oxidation state, right?
Yeah.
And when they have a positive oxidation state, that means they are cations, right? And remember
Yeah.
what we learned in electrolysis. For example, I have Na plus and Cl minus. So Cl minus, this minus tells you that Cl has extra electrons to give off,
Right. Yeah.
right?
Yeah.
For example, sodium is more reactive. Okay. That means that its ability to lose electrons is greater or lesser. If I tell you that it's more reactive.
It's it can lose electrons more easily because
Right. So basically, its ability to lose electrons is greater in this case.
yeah.
And if I talk about non-metals, fluorine and chlorine, and if I tell you that fluorine is more reactive, then we can say that the ability for fluorine to gain electrons is greater. Why? Because it's more reactive,
Yeah.
right? So in group 1, the reactivity increases down the group, okay? And why does that happen? Group 1 may we have metals like lithium, sodium, and potassium, okay? So if I talk about lithium, after lithium, like below lithium, there's potassium, there's sodium, and then there's potassium. Like if you look at the periodic table like this is your periodic table, right? It has a lot of elements. So lithium, sodium, and potassium are somewhere here, okay, in group 1, right?
Yeah.
So if
Yeah.
I were to talk about the reactivity in comparison with each other, then lithium here has a lesser atomic radii. What's the atomic radii? This is your atomic radii.
Is it just like the atomic radii, the force of attraction, or is
Yes,
it different?
exactly. So greater the atomic radii, weaker the force of attraction.
Okay.
Greater the atomic radius, weaker the force of attraction. And why is the force of attraction weaker? Is that the force of attraction is determined by the electron, by the distance between your nucleus and the valence shell electron. So if I have another element that is sodium, sodium's atomic radii is even greater, right?
Yeah.
Now, my valence shell electron is more away from the nucleus. That means that this sodium metal has a much weaker force of attraction than lithium.
Okay.
And as I keep going down the group, my atomic radii keeps on increasing. So basically, if the atomic radii keeps on increasing, the force of attraction keeps on becoming what?
It keeps on increasing, weaker.
Yeah, exactly. So the radius increases and the force
Decreases.
decreases, right? So when the force decreases, that means if this has a greater force, if I were to say that this has a greater force, right? This has a much weaker force and this has an even weaker force. So the reactivity is determined by the force of attraction. So if I have another element here, maybe I have like air here, okay? I have air here in the surroundings. So air will react more readily with which of these?
Uh, uh, Lithium.
No, it's going to react the most readily with
Y- uh,
potassium. And why is
Potassium.
that? Because the atomic radius has increased. That means your force of attraction, the force that keeps this electron with the nucleus, has weakened. That means this electron will easily be able to react with the air around, right? जितना ज़्यादा force of attraction strong होगा, उतनी मुश्किल होगी electron को to react with air around, right? So abhi your force of attraction is strong. Here your force of attraction is weak. Here it's weaker,
Yeah.
right?
Yeah.
So when it's weaker, when the force is weaker, that means it's going to react more readily, right? Get this?
Yeah.
So when it's going to react more readily, that means the reactivity is going to increase,
Yeah.
right? So basically, that's what they mean when they say get down the group, your reactivity decreases or increases.
For which one, lithium or potassium?
Just generally, like down the group,
Oh,
you're
it
going down the
increases.
group like this.
It
Down
in-
the, okay? Now when you're going down the group, you're going down the group like this: lithium, sodium, and then potassium. Okay. So potassium reacts most readily. That means it is most reactive, right?
Yeah.
When it's most reactive, that means going down the group, your reactivity increases, right? Right?
Yeah.
You get this right, or do you want me to explain this thing again?
I understood it.
Okay, great. So down the group, reactivity of group 1 elements increases because the ability to lose electrons increases due to the increase in atomic radii.
Yeah.
Now we come to the melting and boiling points. So down the group, the melting point decreases due to an increase in atomic radii. It has the same explanation just as I explained here. So basically, when there's a stronger force, when this force is strong, that means it's not going to melt that easily. And when this force is weaker, it's going to melt more easily. And when it's more weak, it's going to melt even easily, right? So when the atomic radii keeps on increasing, the force keeps on getting weaker. And the more the force gets weaker, the more the reactivity increases and more the melting point decreases down the road. Okay?
Right, okay.
Now we move on to the density. These metals are less dense than water. What this means is, okay, if you were to put a piece of one of these metals inside water, they're probably going to float on the surface of water. If I have a
Yes.
glass of water here and I put in a cube of sodium, for example, this is a cube of sodium, it's going to float on top of the surface of water. But basically, the thing is that since they're so reactive, if I were to keep a cube of sodium inside water, it's probably going to start reacting extremely violently. And when it starts reacting, it's going to finish, right, at some point. But before it actually starts to react, it's going to stay on top of the surface of water. And why is that? Because it's less dense. And now we're going to see how these metals react when they're placed in water. Reactivity of group 1 metals when a piece of group 1 metals reacts with water. So again, if I have a beaker that has water inside and I put in a piece of group 1 metal, how is the reaction going to look like? So basically, what's going to happen is, firstly, it's going to float on the surface of water. It's going to be a fast, rigorous reaction. Why? Because your group 1 metals are the most reactive. And this is going to be an exothermic reaction. Why? Because heat is going to be given off to the surroundings. When this happens, bubbles of colorless gas. What colorless gas is this? Bubbles of colorless
Hydrogen.
gas are going to be formed, and this is going to be a fizzing reaction. Yeah, what's the name of this gas?
Hydrogen.
Right. Basically, this is your H2 gas. And when this happens, since it's an exothermic reaction, the temperature rises. The temperature of the system rises. So here I'm going to write an example equation for this reaction. For example, if I'm putting sodium inside water, this is what the equation is going to be like. Sodium plus nitrogen is going to give you NaOH plus H2. And this H2 is going to be a colorless gas coming out as fizzing reaction. Okay. Now we move towards oxidation states of group 1. What is the oxidation state? First, we're going to discuss that. I'm going to write the definition for this. Oxidation state. This is the ability of elements to combine and this is also known as the valency of an element. Okay. Now we talk about stability. What makes an element stable? This is going to be stability occurs when the outermost shell of electrons, that is the valence shell electrons, is complete. So if I compare a normal gas, for example, hydrogen, okay, maybe I compare argon, for example. Argon, and I compare a set of noble gases. So we know that in noble gases, the last shell, that is the valence shell, is complete, right?
Yeah.
The valence shell has 8 electrons inside it, right? So that means no matter how many electrons argon has in its valence shell, it's probably going to be less than 8, right? Wait, argon
Yeah.
is a noble gas. I took the wrong example here. If I have a gas, for example, if I have oxygen, for example, okay, and I compare oxygen and noble gases. So basically, your noble gases are more stable than oxygen. Why? You tell me why.
Because they have a full outer shell.
Exactly. And when the outermost shell is full, when it's complete, that means the element is more stable, right?
Yeah.
Now we move on to group 2 metals. We're done with group 1. These metals are called alkaline earth metals. Okay. Now, since we've already done the explanation part for reactivity, for melting points, etc. So we're only going to be writing the notes now. But if you still have any questions, just drop me and I'll explain it to you again. Okay. So
Okay.
in group 2 as well, the reactivity increases down the group. Why? Because there's an increase in atomic radii, and when the atomic radii increases, the force of attraction decreases. And when the force of attraction decreases, the electrons react with the air around or whatever is around them with like elements or anything more readily. Why? Because the force of attraction is weaker, right? It easily breaks off, which is why the electrons can react with other things in the surrounding.
Right.
So the reactivity increases while the melting point decreases down the group. Here's an example for this. For example, I react calcium with water. I get calcium hydroxide and H2. Just balance this equation. This is going to be 2H2. And yeah, that's it. It's balanced. So this is what the reaction is going to look like. Calcium is a group 2 element that reacts with water to give you calcium hydroxide and hydrogen gas. So group 2 metals react very much similarly like group 1 metals, but they're a bit less violent. Why? Because they're a bit less reactive than group 1 metals. Both are extremely reactive, but if you compare them, then group 1 tops in reactivity. So group 2 metals react. Just give me a minute.
Okay.
Okay. So group 2 metals react very similarly like group 1. They react similarly like group 1, but less rigorously. Okay?
Okay.
Now, when we talk about oxidation states, the oxidation state for group 2 metals is 2 plus. Okay, they lose 2 electrons or gain 2 electrons, right? So
Yeah.
if I give you an example for magnesium, its electronic configuration as an atom is 2, 8, 2, while if it turns into a cation, that is Mg2 plus, what is its electronic configuration going to look like? Okay, just as a hint, it's going to lose 2 electrons,
Yeah.
right?
Because it has an oxidation state. It's just going to be 2-8.
Right, so it's going to be 2 and 8. Just like that, if I have calcium, for example, my electronic configuration as an atom is this. What is it going to be as
2-8-8.
a cation? Right, it's going to be 2, 8, and 8. Basically, these 2 electrons are going to leave. Now we come to group 3. There is no name for group 3. Okay. Also, the meeting is going to end in 4 minutes, so rejoin whenever it ends.
Okay.
So a lot of these groups do not have a lot of information to them. What you need to focus on majorly is group 1, group 2, group 5, and group 7. Okay. So in group 3, there is not a lot of information except for one point, which is about oxidation states. So oxidation state for group 3 metals is 3+. Then we move on to group 4. This also has one point in oxidation states. So oxidation state for group 4 metals is 4+ or 4-, right? Now we come to group 5. This has a big chunk of information. So when we talk about group 5, there is a nitrogen in group 5. There is phosphorus in group 5. The electronic configuration for both of them. For nitrogen is going to be 2,5. For phosphorus is going to be 2,8, 5. So when you move to group 5, the oxidation starts getting to a negative number, right? So basically here what's going to happen is, what do you think? 5 electrons are going to leave, or it might just take in 3 electrons to complete its octet?
Yeah.
I'm asking you.
Yeah, 3 to finish it.
Yeah, it's going to finish it, right? So when it takes in electrons, that means it's going to have a minus oxidation state, right?
Yeah.
So if it takes in 3 electrons, that means the oxidation state is going to be -3, right?
-3.
Here the metals were losing electrons, right? So losing electrons means that the oxidation state is a positive oxidation state. And gaining electrons means that the oxidation state is a negative oxidation state. So what phosphorus is going to do is the same thing. It's going to take in 3 electrons from any element it's reacting with. It's going to complete its octet. And the oxidation state is going to be a -3, right? So
Yeah.
the ion form of nitrogen, what's the electronic configuration going to look like?
Um, 2, 2, 8.
Right, very good. 2,8, because it's taken 3 electrons from some other element. If I were to talk about phosphorus, what's the oxidation state for this wood?
2, 8, 8.
Right. 2, 8, and 8. Now we move to group number 6. Group number 6 has elements like oxygen and sulfur. So what's going to happen is